Thanks for taking your time to attend this session today. This is the last session. I know we are starting a couple minutes late, but I promise that we'll end on time. With that, the session is about global visibility and control for Consul. My name is Sridhar. I'm product management lead for our Consul Cloud business. As we get started, just a quick show of hands. How many of you have used Consul? That is wonderful. How many of you are in DevOps or infrastructure management role? That is, again, so beautiful. Perfect fit for this session. Thank you. So I still see that for some that have not used Consul, I saw some hands down. For their benefit, Consul is a service discovery and service management, service mesh tool. The problem that it solves is it makes it super simple to be able to discover and connect services irrespective of the runtimes or the environment that they are in. Meaning it can be in multiple clouds, multiple data centers. Consul helps discover and connect those services. That's the context. Now, the problem space that we are in is about multi-cluster management. Adding to that is the problem of complex workflows. How do we make it simple such that the time to market is quick? That's the problem space. So I'm going to go dig a little bit deeper into the problem space. And one thing I missed to say is within Consul, it's offered in open source. It's available in enterprise. In terms of deployment, you can use a self-hosted software of Consul, that is, you deploy in your own infrastructure, or you can deploy Consul, or you can use Consul, consume Consul as a service in HashiCorp Cloud Platform, where we manage Consul for you. So those are the flavors of Consul. Yeah? Perfect. So let's start off with, as I said, we'll dig deeper into this problem space by setting some context. We'll start with the infrastructure deployments. Where is it at? First trend. You've heard this yesterday, today, Dave McJanet in the keynote, Armon. It's essentially that there is a central platform team that offers built-in services. Why? Number one, it enables a consistent and predictable deployment. When I say built-in services, imagine that an app team says, I'd like a Kubernetes cluster. The platform team says, okay, give me your VPC account or your Kubernetes cluster ID. Then they get the credentials to go set up that cluster, or in fact, create a new cluster, put a lot of services like a logging service or observability service, etc. And all the platform team needs to do is get started deploying their applications. That way, they get started very quickly. We'll talk about friction in a second as well. So that's one. Predictable deployment. It's also secure, because the more you templatize it and repeat it, it's secure. The second trend is multi-cloud or hybrid cloud. In fact, it's happening as we speak. One thing, the revelation for me is after I came here is not only is the cloud going hybrid, our lives are also going hybrid. Hybrid work, hybrid conference, virtual, real. So a lot of things, too much on hybrid. The use case that I often remember, I hear from customers when I talk to them is, VMs are in our legacy. We have VMs, legacy application, connected to a database. We cannot move that to the cloud, but we are moving greenfield applications to the cloud. Those applications have to talk back to the database. Classic example of a hybrid deployment. In many cases, hybrid is a journey, meaning hybrid is a path to a journey of migrating to cloud. In some cases like this legacy application example, hybrid deployment may be something that will stay forever or stay for a long time. The third is DevSecOps approach. And I know it may sound like a buzzword, but it's getting a lot of traction. Basically, security teams getting involved early on in the planning, implementation, and enforcement practices, such that security doesn't become an afterthought. Or in other words, the deployment is secure as it's built. So, and it's a continuous process. It's a philosophy. It's not one team. It's a philosophy of teams working together to make it happen. Last, I love this one because I'm in Consul Cloud, is the desire to consume infrastructure as a service from enterprises. May be obvious, but I'll still state it. Like one, time to market is very fast. You go make a couple of push button clicks, you get something started and you move on. Second is it bridges a skill set gap. If you host on your own, you have an obligation or you have a responsibility to operate and maintain. And the third is it eliminates fixed costs. Fixed costs as in this, the need to deploy human resources to be able to operate it. So these are the top trends that I was able to summarize as we were talking with enterprises. Next, when it comes to application deployments, one is microservices. I think there's no more need to double click on that, it's clear. The second thing is interesting, heterogeneous runtime. As enterprises are deploying microservices using orchestration patterns like Kubernetes or Docker, ECS, the thing still remains that there are applications that are still running on VMs, and also new technologies coming in, like serverless. You know, Lambda. You would have heard about Lambda in Consul announcement today. So there is also another factor. Application team determine which runtime is best suited for their applications. So there will be a natural heterogeneity that will happen. The other factor is skill set. Some teams are more comfortable with writing Lambda code, some are not. So application team typically makes the choice of which runtime they want to run at. Third is agile teams. Again, teams have their own, these days in the digital world, you know, agility is the new currency. So teams have their own velocity in terms of feature rollout, capability rollout, and they don't want any shared fate. We'll talk about that down the slides, how it impacts, how these emerging state impacts the overall system. Now, when it comes to factors that impact operational complexity, when I say operational, let's pretend this operation in the context of Consul or any other service mesh technology. There are multiple factors. One clear direct factor is how many Consul servers or how many control planes that you run certainly has an impact on the complexity, right? And what factors determine how many runs? And that's what I've outlined here. Number one, environment. I've just listed a dev, prod, staging, test, typical environments. But there are companies where they have environments that are close to production but that are open for partners. You know, so sometimes the number of environments, which means each environment, they will have different sets of control planes, that increases. The other is multi-region, multi-cloud. There are good reasons why enterprises choose multi-region. In fact, application teams choose multi-region. Why? If you think about it, when it comes to satisfying their end customer, they want to put applications closer to where their end customers are. And that creates a need for multi-region. The other scenario is disaster recovery or business continuity, multi-region. The reverse scenario also is that while you're taking some of your applications in a sets of region, there may be shared services located in one or few regions due to compute cost, maintainability, etc. Therefore, the applications in different regions have to cross-connect across regions. Again, when we talk about complexity, we are not only talking about operational overhead, but also how do you manage these networks, secure these networks, you know, creating a zero trust posture. Third, dedicated clusters. What I mean by this is typically platform operations team recommend or encourage the app devs to run their services in a shared cluster environment. No problem. In fact, Consul's enterprise version supports a concept called admin partitions, which essentially takes a physical server and logically breaks it into multiple virtual servers, control planes. So it's there. However, there are scenarios where enterprises may choose to deploy dedicated servers. Let me give you an example. Compliance reasons. PCI compliance requires, if somebody plays it by the book, they want complete isolation, and therefore the easiest way to have complete isolation is to have dedicated clusters. Second is ring fencing for resources. If supposing there is an application that has heavy load, you don't want the control plane to get choked for other applications because of one other. So therefore you want to ring fence due to resources. So these are some of the reasons. Last, we talked about heterogeneity. Sometimes it so happens that there is connectivity issues, connectivity constraints between runtimes. I have a VPC CIDR for VMs. I have a separate K8 CIDR, but my security team doesn't allow these two to talk to each other. Therefore, you have to deploy Consul, in this case, Consul or any other service mesh control plane, locally within that runtime, right? All the above factors increase the number of control planes, therefore, implicitly increasing the management complexity. We are talking about management complexity or operational complexity because we are trying to figure out a way to devise a solution for that down the presentation. So that's the context here. Now let's talk about teams. We have talked about the operations part. A big portion of innovation is reducing the cost of change. One of the key cost of change is collaboration between teams. What I have here on the slide is a general segmentation of roles. Some companies may collapse these roles into one, but some companies may have multiple other roles for each of these functions. But broadly speaking, in order to implement zero trust security, these teams have to come together. What that means is their expectations for workflows have to be met. Each of these teams have different sets of workflows that we'll talk about in a second. So broadly, I like the 2x2, so it makes it easy on the eyes. So one is implement, that is infrastructure ops teams to implement the technology. SRE teams to operate the technology. In some cases, SRE teams also takes over to a greater extent in influencing the implementation. Security ops team for audit and enforcement. App teams, consumers of the infrastructure. So let's talk about what do individual teams or roles need. Platform ops. The first one is simple. I want a single pane of glass. I've heard this so many times from talking to customers. The other is minimizing integration. When we talk about integration, if you think on the northbound side, there is incident management system like ServiceNow, alerting, logging systems, connecting to CMDB as the asset management source of truth. So there are a lot of tools to integrate and a lot of functions to integrate with. And platform team's goal is that currently we have a tool sprawl in the industry. So their goal is to minimize the tool sprawl, standardize to a set of tools, complete the integration, make it easy. Reduce app developer friction. App developers are the internal customers for the platform team. So, keeping them happy or keeping them productive is super important. Let me give you an example of one of the discussions or a pattern that I've seen in the last recently about app developer friction. The platform team has created a beautiful way of using Terraform to deploy the applications or the infrastructure very quickly. All great. Now, one of the requirements that they have, the corporate has, is that all the microservices have to talk to a centralized API gateway. And guess what? Once the application is deployed, that's like about an hour to set it up, everything. And then to get to the API gateway, it's like 6 weeks. So you're done right there, because this is called friction. So these are some of the use cases that Consul is designed to solve. Because for east-west traffic, you don't need to go through a centralized API gateway, but yet get the functionality of, blue-green deployments or looking at the header and manipulating destinations based off of the header. All these things are possible with mesh. The last part is scale. When I say scale, it's human scale. For the platform teams to support hundreds and thousands of developers, they need to be able to, have templatize and automate tooling. So scale is of utmost essence, otherwise the platform team cannot support hundreds and thousands of developers with a few staff. When it comes to service mesh, one of the things that I have recognized over a period of years is there are two ways to offer service mesh. Service mesh as a service mesh as an infrastructure. In my opinion, the best thing I've seen, where I've seen companies succeed is offering service mesh as a service for their developers. And what I mean by that is they don't expose service mesh to their developers. Their developers call an intent, and the scripting or the templating that the platform team provides makes it happen. It's abstracted away from the developers. That's the trend that's starting to happen. Now let's talk about security ops teams. Enforce best practices and also audit for security and compliance. Let me be very specific. Security team wants to know, this is some of the examples that I've heard from customers recently. Security team wants to know how much of vulnerable envoy is there in the fleet. They also want to know if an application is tagged PCI DSS, meaning the PCI DSS standard, what are the connectivity from that service, especially whether that service is connected to an ingress gateway, because that exposes the service. They want to be able to see that without having to go raise a ticket, somebody coming in and then doing an analysis, coming back in 4 weeks, telling too late. So these are the needs. Next, app dev teams. Simply speaking, they want the infrastructure to be invisible to them. If you have heard of some of the talks today that talk about how they automated the infrastructure deployment using GitOps, that is essentially the gist of what the application team wants. They want the infrastructure to be invisible. The next is discover and connect to services. Many times, applications team don't know what other applications are available that are developed by other teams. And I have spoken with enterprises, not the highest scale, but in the mid-market. What we have heard is they use Confluence. They sometimes use Excel to know which team does what. So there is no easy way for teams to find out what are the services deployed by other teams. Now, we have talked about some of the needs here. Consul today doesn't provide a global view, and global view is critical to solve some of these problems. When I say global view across all these clusters. Let's see why. So when it comes to this multi-cluster management, Consul has supported this concept of federation. Let me break the title into 3 parts and walk you through this. Federation, operating model restriction, and global view, limited global view. Federation is the ability to connect Consul clusters. The concept of federation works by assigning one Consul data center as a primary. In this case, you can imagine data center 1, Consul data center 1, and the others are secondary. Now, that's the way it works. And it works beautifully to enable this multi-region, multi-cloud connectivity. It works well. But it assumes some operating model restrictions. And what are they? Number one, it assumes that the keys for all these Consul clusters are shared. By that, it assumes that there is a single operator that manages across the board. Secondly, there are some configs that are global in nature. If you see that diagram on the board, it says service owner config that's like shared. There are some, for example, if you take namespace in Consul in this federated case is assumed to be global, which means that care has to be taken to avoid conflicts between teams. And if you think about it, teams want to be independent. And if you have to coordinate, it takes time, and therefore it slows down. Third is, within this whole fleet of clusters that are federated, there has to be care taken to make upgrades, version upgrades. Secondary has to be updated before primary. There are some rules. So in short, federation has its own benefits, but it also has some tight controls. When it comes to cloud, we talked about multi-cloud, etc. So we love the new feature called cluster pairing because it doesn't have the concept of shared keys. Every cluster is independent, and they have a loose coupling between them, the loose contract between them. When I say loose contract, if there is a service B in cluster B, and if I want to expose that service to service A in cluster A, I have to author an explicit config that says, allow service A to access me. That's so beautiful because that has tight controls. and it makes it independent. And it also allows the self-managed cluster to be able to talk to the HashiCorp managed cluster, because we no longer have shared keys. But it creates visibility problem. In the case of federation, I could go to the primary console UI, primary console data center's UI, and I can click the secondary data center, and I can see the list of services. That was the limited view, global view. But I had to then somebody had to set permissions for an application developer to allow seeing those UIs. Here, the clusters are independent, therefore there's no concept of a global view. Every view is localized to that cluster. If I want to see something, I have to go local to that cluster. So in short, to summarize, we have a gap in terms of having a global view available with Consul when it comes to multi-cluster deployment. So what do we do? What do customers do? So what they do is they build a custom aggregation layer on top of each of these clusters. They aggregate the data, and they do other API calls and etc., authentication, authorization with individual clusters. What does it do? It increases the development cost, it increases operational overhead, and it also increases the time to market because of this development cost. So, now, what is our vision? We want to provide global visibility and control for Consul, irrespective of where it's deployed. Either it can be a self-managed Consul, or it can be a HashiCorp managed Consul. And this complexity of multi-cluster management is not just with Consul, it's with across the board, with any technology, mesh technology that you take. So the goals, that's the vision, and the goals for us is, one, reduce the operational overhead. We want to provide simplified workflows. At the end of the day, reducing the developer friction is super important. And also, reducing the time to market for our platform teams is equally important. So we wanted to reduce the operational overhead, offer simplified workflows, and then reduce the time to market. If you think about the evolution of where we are coming from, we had Consul open source, we had Consul enterprise, then we made sure that Consul is available in the cloud as a managed service with HCP AWS in 2021. 2022, we released HCP on Azure, so we went multi-cloud. So we have the footprint. Now it's time for us to think about and solve the problem of this multi-cluster management. So with that vision, we said, okay, what if we develop this solution as a hosted service on HCP? Let's break this into two. Hosted service, HCP. Why a hosted service? We talked about in the earlier trends that enterprises want to consume infra as a service. Nobody wants to be in the business of managing infrastructure. We talked about all the pains with that. So that's why it's a hosted service. Why on HCP? HCP is a natural choice for us. Because if you see HCP today, if you go create a cluster in HCP, like a Vault cluster, Consul cluster, you have one pane where you can go and find all your clusters. It already supports these management capabilities for clusters. And if you think about it as a platform, it has access control, it has the billing capability, networking, identity, logging, notification service, and then resource allocation service. So we have a bunch of services already built into the HCP platform. And importantly, it has multiple other HashiStack services. Last, HCP is a SaaS. So we get to provide our users with the velocity of SaaS, feature innovations faster on a daily basis. That's why we picked HCP. With that, we are really excited to announce the global visibility use case in HCP for all Consul deployments as a tech preview by the end of this month. So, and we'll see what the capabilities are in terms of these tech preview features. With this, we can bootstrap a new Kubernetes self-managed, self-hosted cluster, meaning a Consul cluster in your deployment quickly. And you can also view all the lists of services, clusters, the service catalog, servers and health, all across in one management plane. So Please join our waitlist in the URL here, and we'd love to hear your feedback. So with that, let's get into the demo. What I'm going to do is I'm going to give a voice to a video that we recorded. First, I've segmented this video into 4 kind of steps. The reason is we could walk through the workflows for the platform ops as well as the app dev persona. Okay? Let's take the scenario where we have a DevOps or a platform ops team that's supporting multiple lines of business application teams, and each of those application teams have different requirements. Some want to run on-prem, some have a hybrid, and some have everything in the cloud. So how is the platform team going to do this? Let's walk through this. Okay, first is cluster setup. So the platform team, they first create an account in HCP, and they set up their SSO, single sign-on with the IDP. They're ready. Now they are good to go. So they click on Consul, and then they go to the Consul page. They are presented with 2 options. One is for HCP managed Consul, and the other is for self-managed Consul. It compares and contrasts the benefits of both. For a first-time user, it also provides the videos on the different use cases, as well as the other educational materials. Our platform ops selects self-managed Consul, and they like their one of the teams, Team A, better. So they want to bootstrap the Team A's cluster. It's Team A and in Austin data center. So the platform ops team is going to set it up for their apps team. Once they do that, HCP provides a blob of code. This blob of code contains the authentication and authorization to bootstrap a remote cluster with the cloud. Okay? First, the platform team checks whether there is a K8 CLI deployed, because it makes it super easy to deploy this if you have a K8 CLI. CLI is deployed. Okay, great. Now they copy the blob of code. Perfect. The code runs, and it shows the config that Consul is used to deploy this. While it's installing Consul, the cloud detects that once the user have done this, the cloud detects that there is a remote connection coming in, and it's authenticated. It started. User goes back, and as you can see in this screen, we are showing that the Consul install is complete. Once it's complete, there you go. It's bootstrapped with ACLs and TLS, very secure bootstrapping, and there you go. Consul is discovered right in the services menu of the cloud. So the first step is done. Still not done yet. Only the first step. So the platform team is great. They have bootstrapped a cluster, got it ready for the apps team. Now, now they told the app team, hey, your cluster is all ready. Your Kubernetes cluster is ready. I've deployed Consul in your kube cluster. I've added you to the HCP org. So now, what's your next step? App team says, look, I'm going to go deploy a test application just to play with it. So that's the next step. App team is going to go deploy their app. And that app is HashiCorp's. I love this one. So that's it. So HashiCorp's app is deployed. That's done. So the app team has deployed their app. Now comes, okay, what is the next logical thing? There are 2 things, day 2 operations, day 2 activity that both these teams have to do. The platform team is very quick. They have also catered to the needs of other teams, and they started spinning up clusters in the cloud, using the cloud. It's a couple of push-button deployments. They have done that. And so they wanted to check how the health is. Whereas the platform team, now that they have deployed the services, I have to set up policies, right? Because Consul is denied by default. You have applications that HashiCorp's app is there, but unless you set up the intentions, nothing will work. It's because the services don't communicate intentionally by design. It's secure by default. Okay, so the platform ops team logs in. Imagine that this is platform ops team logging in. They look at the cluster. They get a holistic list of clusters that they have deployed in the last couple of days, besides this Team A. Team A will show up in the bottom. What it shows is there are total number of clusters between self-managed and HCP, and then it shows services and the service instance count that kind of add to or that belong to these services, and the health of these service instances at this current point in time. So the reason it shows version 114 below, etc., is because in order for this to be discoverable, to be aggregated with services and service instances, we require Consul 14.114. And that is why it shows which versions are 114, which ones are not. Like, let's pretend that you have a HCP cluster with 113. It will still show it in the list, but you will not see the service and service instances. It requires 114. That's the point. Okay, great. So the ops team is happy. They are able to get everything in one snapshot. Then comes this app team. They come and pick up their cluster. Oh, I see my Austin DC. Yes. What do I want to do? I want to set intentions. But let me click. I have the Consul UI right here. I can access the Consul UI right here. I don't have to do any load balancing, making it available. Nobody has to do it for me. I go to the cloud. I've already authenticated safely. I'm accessing my UI, beautiful. Now I want to set intentions. We deliberately created the product service failure because when you see finally, it will show it in the health score. Okay, I'm setting allow all services for now just to play because it's my dev environment, and that's it. So I've allowed it. If you notice on the previous screen that I showed, along with the access UI, it also showed the health of the servers. So as an operator, I can also see within that cluster, how are the individual servers doing? So that's for the operator as well. Okay, so this step is done. Now we have one last step. The operator is all clear now. The platform ops team is all clear. Okay, discovering services. So one of the things that the app team wants to do is, there is an app team C, okay? They want to connect to a backend database, this HashiCorp app that is hosted by the team A. But they don't know, they wanted to connect, but they don't know whether it exists, and especially if it has mesh in it. Because if there is, then they can have a mutual TLS connection going between their service with this backend proxy, with this backend service. So what do they do? So they go to the services tab. Now the services tab lists all the services, and if the service has a sidecar proxy, it lists that as well. As you can see, the team C has found that there is a Postgres, and they can clearly see which Consul DCs they are all located. So now they know that it's enabled with mesh and where they are located. So it is a stepping stone for something that we can do in the subsequent releases. Okay, so let me summarize. Our vision is to have global visibility and control for Consul. And our goals are that we wanted to reduce operational overhead and provide simplified workflows. If you can imagine, what we have in the tech preview is a step towards that vision. We could do a lot. What we have now is a management plane that can look at all the clusters in the deployment, self-managed or HCP. So if I have to give a sneak peek of what we are thinking next, looking ahead in the future, one, can we bring in and connect all these, can we create workflows, simple workflows to connect all these existing clusters to the cloud so that customers can benefit from the innovation here? Second, can we create APIs so that if our platform team wants to build additional layer with minimal tooling, they can consume the APIs and build a self-service portal for their application developers. Third, we talked about simplified workflows a lot. Let's take an example of cluster pairing we talked about. Can we provide a simple workflow where the user, the platform ops team says, I want these 4 clusters to be paired, and that is it. They don't, if you look at the current implementation, users have to take a token, carry it over to the other cluster and include that. We can eliminate those steps. That's one of the examples of simplified workflow. The other is telemetry. The fact that we are able to connect to a remote cluster and get metadata, not data, metadata from that cluster means that we can increase our ability to have telemetry to help with getting started and or troubleshooting. So there are a lot we could do. We have created a platform. And please join our waitlist again. My request is please provide us feedback. It will open up on the 31st of this month. Last is, before I wrap up, we talked about multi-cluster simplification. There is also another set of enhancements or features that we are planning for relative to connecting data planes or workloads with the Consul server in the most simplistic way. Irina Shustava is presenting tomorrow at 2:30 about what are the features that we're introducing to connect the data planes easily, seamlessly with the Consul server in Kubernetes. I request you to attend that session. That would be very informative. With that, I wanted to say thank you, and over to Nick.